Okay, friends, so this video is on solving trig equations, and it does say see book page 362, so I'm just going to pull that up for a second because I want to show you kind of graphically what we're doing. What we're doing is we're trying to find where our sine or cosine function, and other functions, but let's just start with sine and cosine. We're trying to find where our sine and cosine functions hit a certain value. So if you look at this right here, you'll see that our sine and cosine functions are cyclical. And if we're looking for where a sine function or a cosine function hits a half, we're going to find that it hits a half a whole bunch of times. And you'll notice that from pi over 6, it's going to go back and hit a half 2 pi later because we're cycling through the whole thing. And since sine hits a half at 5 pi over 6, we're gonna hit that spot again 2 pi later. So if you take this right here and you add 2 pi, you get this value. If you take this and you add 2 pi, you get this value. And what would happen if I extended this graph? I would have to just keep adding 2 pi and I'd keep getting these same answers. Or I could take away 2 pi. If I take this and I take away 2 pi, I'm here. I went left 2 pi. If I took this and I took away 2 pi, I'm here. Subtract 2 pi. So whether I add or subtract 2 pi, or whether I add or subtract 4 pi, or whether I add or subtract 8 pi, or whether I add or subtract 232 pi, right, as long as it's an even, I will get another answer based off of pi over 6 and 5 pi over 6. Those are the key numbers to know. So that's sort of what we're trying to do. So let's see if we can kind of bring that back to algebra. That's the graphical understanding. And I think that if you're in my class, you've probably done problems like these, and they're probably not too big a deal. So we'll go at a pretty good speed here. What we're trying to do is trying to isolate the sine expression, I guess, the trig expression. We end up with something like this: sine of x equals negative root 2 over 2. Okay? And we've solved this on 0 to 2 pi many times, I think. So on 0 to 2 pi, we solved this many times, but I'm just going to X that out. We're not going to solve it on 0 to 2 pi. We're going to solve it forever and ever and ever and ever. So let's visually look at where this might be. This is definitely a pi over 4 situation, right? Pi over 4, question mark? Because that's the reference angle. That's the triangle that gives you root 2 over 2. So with our all students take calculus, we see that we're not going to be in all our students because of this negative sign. We're going to be in taking calculus. Now if we look at where those are, one branch is going to be here. That's a pi over 4 in that quadrant. And that's a pi over 4. Why? Because this is pi over 4. This reference angle here is pi over 4. This reference angle here is pi over 4. So the question is, what is that blue line representing? Because that's x. X is going to be that. So we'll start with the blue. X is going to equal 5 pi over 4. But if I take that and I spin around once or twice or 3 times or 4 times or 5 times or 6 times, and you get the idea? Every time I spin around by 2 pi, any amount of time, so I'm going to put an n here, where n is an integer. That's what that means. I put a comma there. You can put a space. That's what's going to happen. So this is our answer. We'll look at the next one. We got something going on with our loudspeaker here. Hopefully that goes away soon. So we have x equals, what's this guy? This is 5, 6, is this 7 pi over 4? This would be 8 pi over 4. Yeah, so 7 pi over 4. Okay, and then we're going to add 2 pi any number of times. You could put any number there, 1, 5, any integer. 1, 7, 90, negative 80, whatever you want. It's going to be an answer. Okay, so some multiple of 2 pi. So that's pretty much it. I think that's kind of okay. You guys think that's kind of okay? This part? It got pretty dicey yesterday with some of the activities we were doing, so let's see where it goes from there. So let me not skip an example. I'm going to skip the checkpoint, assuming that you're kind of okay. This one I think you're okay with too. To be honest, I think you have done this one, this exact problem, honestly. But maybe you did it on 0 to 2 pi. So 0 to 2 pi was what you did it on before. So before it was like solve on the interval 0 to 2 pi. Now we're not doing that. We're just solving. Solve, period. That's it. Solve. So we're going to isolate the tangent. Ah, geez. For those of you joining us online, we're dealing with some white noise here on our intercom system. But luckily, we have a high-quality mic, and you probably don't even have any idea about that. So that's great. Okay, so we're going to square root both sides in this case. What do we have to remember when we square root both sides? Plus or minus. Yes, this is a common mistake. So we're going to have plus or minus, I guess, 1 over root 3. For now. I'll rationalize it, I guess. And that's just going to be tangent of x. So that's good. So tangent of x equals that. Okay. So let's rewrite this into our two things. It seems like we'll have tangent of x equals root 3 over 3. And we'll also have tangent of x equals negative root 3 over 3. Now let's try to visually figure out what's happening here. As we look at this, for the blue one, root 3 over 3, 1 over root 3, I think that's a pi over 6, yes? Sound like a pi over 6 to you? So I believe we're going to be at pi over 6. But also, tangent is also positive over here, so we'll also be here. Now there's two ways to write this answer. One way is definitely better, I will tell you that. But what we want to understand is that x is equal to pi over 6 plus, how do we get from here to here? How far is that? I'll give you a hint, it's not 2 pi. It's pi. So what we can actually do is we've taken care of the first answer and the second answer by adding pi n. Because this is pi, and then if I add pi, I'm here. 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 And you get the idea, right? So it's kind of nice because now that's over. That's it. You could have written it as pi over 6 plus 2 pi over 2 pi n and pi over, I guess 7 pi over 6 plus 2 pi n, you know? But then you'd be like double counting answers. You'd be like giving answers multiple times. It'd be kind of like weird, you know? Like double dipping, so to speak. Okay, so then we got this guy going on. All students take calculus. Definitely not in all or take. So we're here. We're also going to be a pi over 6 version. So we're going to be here and here. Do you notice that they're beautifully, like, they're totally opposite, reflected, or whatever you want to call it? They make a straight line, if you will, right? That's why you can add pi. Tangents are weird like that. So x is going to equal, this is going to be 5 pi over 6 plus, and now tangent's different. We add pi each time, every time we go halfway around. So it's pi n, and that's our other answer. Okay? So that's how we solve those ones. I think that's where everyone is probably feeling pretty comfortable. We're probably feeling comfortable up to this point, and anything after this point is where it starts to become a little tricky. I will skip the checkpoint just in the interest of time and try to get through this next one, but I'll slow my roll a little bit now. So you see a star there for factoring. We haven't really done too much of this. We factored for sure. This is what I would call new material. And we tried to do a little bit of it yesterday with this activity that we did. What's the deal with this? Is this all the same trig function? That's my first question. No. It's not going to be good. So, tip. Just one trig function. What that means is all sines or all cosines or all cotangents, right? So which one do you think you can swap out easiest? The cotangent? You could. You could also swap out the cosine squared, but I don't know that that would really help because that would just get you a sine squared of some sort, right? Some type of sine squared. So maybe it is best to do the cotangent. It wasn't my initial thought, but this is sine of x over cosine of x. No, is it? No, it's not. This is cosine of x over sine of x. So we're just trying something, okay? So be ready. Have your eraser ready if this doesn't work. It's okay, because even something wrong can really be helpful. Okay, so here we are. We have that. Now we have cosine of x over sine of x. Okay. So let's deal with this. What I want to do is I want to move things in factor. I want to be very careful about dividing by something with a variable. You know what I mean? Like, you know how like if you have like x squared plus x equals, I don't know, like let's say x squared plus x equals like 5 or something, you wouldn't like, it's not really like common to like divide by a variable. It's not really the done thing, okay? Because you can lose answers that way. So we don't, I know that some of you are probably thinking, hey, I should divide both sides by cotangent. Were you thinking that? Anybody thinking that? That's okay, I get it. But you'll lose answers if you do that. You'll basically, instead of maybe having 2 answers, you'll have 1 answer. So you can't do it. You can divide by 2, but you can't divide by something with a variable. As a general rule, there's maybe some exceptions. So let's deal with this now. So we have, I guess what I'll do is I'll move everything to one side. So I'm going to say that I have cosine cubed over sine, right? Minus 2, I guess I'll put the 2 on the top, cosine of x over sine of x. And that equals 0. You can check my math. I'm not, I think I'm okay. What are your thoughts on this? I mean, it has a common denominator, right? So if I look at this, cosine cubed of x minus 2 cosine of x all over sine of x equals 0. I'm going to ask you a pretty important question that I need you to kind of like try to lock in and understand. What makes a fraction 0? What makes a whole fraction 0? There's some way to simplify this. What makes a fraction 0? When the top is 0? When the bottom is 0? When they're both the same? What makes a fraction 0? Yes. When the top is 0. So all we need to do is set this to 0. If the top is 0, the whole thing is 0. Promise. If the top is 0, the whole thing's 0. 0 over, doesn't matter, right? So all I'm going to do is now I'm going to focus on this, cosine cubed of x minus 2 cosine of x. We have a much simpler equation now. We just have to really solve that, right? Oh, I wonder how much they're going to want to get into. That's okay. That was just a thought I had. So I've got cosine squared of x minus 2 equals 0. Here's where I'm at. This is where I am so far, okay? I also have this other situation. I don't know how much we get into this, but like, I also realize that sine of x cannot equal 0. This is like a side note. I don't know if we're going to have to deal with this. I wonder how the book will handle it, but this is a side note. Sine of x can't equal 0. Because if sine of x equals 0, the denominator equals 0, correct? That's bad. That's very bad. You can't have the denominator equal 0. So for those reasons, sine of x can't equal 0. So we might actually say what x can't be and what x can be, which is kind of weird, but hopefully that makes sense. Just something to think about. So we'll deal with this later. Just deal with that later. But I'm just putting it on your radar. Because at the bottom 0, that's bad. The top is 0, that's good. That makes the whole thing 0. Okay, so we're solving this red equation. Let's get ourselves some more space. So as you can see, these are, a little involved. So let's just focus on what's at hand, which is this. So what I'm seeing is that I have cosine of x equals 0, and I have cosine squared of x equals 2, if you're okay. I added the 2 to both sides. set them both to 0, added the 2 to both sides, right? And that means that cosine of x here is going to equal plus or minus root 2. And over here we have cosine of x equals 0. So let's try to solve this guy first. X equals something. What does x equal? I'm also going to look at how they handled that sine of x in the bottom. What does x equal for that then? Cosine of x equals 0. Thoughts? Pi over 2 and 3 pi over 2. So I would say pi over 2 is definitely one of the answers. We've got to add something to that. I'm going to visualize it. Let's get this out of here. Come on. Okay, there we go. Bear with us here. This problem is more involved than I expected, but that's okay. We're not mad about it. Okay, so we know that pi over 2, this is 0, 1. This is 0, negative 1. So we know that this is an answer and this is an answer. Cosine is 0 here. So what do I have to add to get from here to here? And what do I have to add to get from here to here? Thoughts? Pi. I can actually just add pi n and be done with this one. It's a little weird because you might have thought that it was going to be 2 pi, you know, because the period of cosine is 2 pi. You could have probably written this answer and then added 2 pi and written this answer and added 2 pi. It'd be acceptable. It wouldn't be ideal, but it would work. Okay, that's done. In any of those situations, do I get an angle of 0? No, right? So that green thing up there that I was talking about is not really a concern yet. But we have to think about it. Okay, let's look at this guy now. Cosine of x equals plus or minus root 2. Thoughts on that? What's the deal with that? What's root 2 roughly? 1.4? I don't know, 1.6? Who knows? Yeah? So if square root of 2 is 1.4, what's cosine of what is 1.4? No solution. No solution. Cosine can't be bigger than 1. So the root 2 is bigger than 1. So there's no solution from this side. So this is all just for naught. I mean, yeah, it could have come out to a solution, but in this situation, it did not come out to a solution. So there's no solution from this portion of the equation. And none of my solutions have 0 in them, which is what we talked about up here. And I don't want to get like down the rabbit hole of this, but I'm just saying the denominator can't equal 0. So clearly cotangent would have been undefined there. This whole thing would be undefined. And that didn't end up being an answer anyway, so it didn't really matter. But I like to call it out. We can't have the denominator equal 0. So that's just something we're going to talk about. We're going to talk about that more in this class as time goes on. But we're good. This is our answer, and n is an integer. So we should say the following. You can just write n is an integer if you want. I don't care. But you will have to start bringing that in, even though I'm not doing a great job about that. Or you can write n is an integer that way. Okay? Okay, I don't know when I broke this into part 2. I'd like you to try to solve that one, but let me see what I've got on the docket here. I'm sure we've been going for a little bit. Okay, so see, it says if time allows. So let's see where we're at with this video. We'll try to complete example 5. We're at 19 minutes. I would say time does not allow. So what I'll have you do is pause the video and try to complete this checkpoint right here. It actually seems a little simpler than the previous one, so that's good news. And I'll see you guys in the next video. Peace.